This is my video report for Virtual Lab 6 Equilibrium. Le Chatelier's principle states that if a reaction is at equilibrium and a stress is applied, it will shift to restore equilibrium again. To demonstrate this principle, I chose to explain 3 different reactions from lab. The first reaction I will explain is experiment B, a chromate-dichromate equilibrium reaction by adding a stress of an acid or a base. And before I explain the reaction, both of these equations are considered to be at equilibrium, and the initial color of chromate was in yellow aqueous solution, and the original color for dichromate is an orange aqueous solution. And when the chromate dichromate were mixed together, it created a light orange color. So using the initial reaction, 2 different stresses were applied, and the first stress that was applied was HCl, which is considered to be a strong acid. And when HCl was added, you were adding more H plus ions, which increases the concentration of H on the reactant side. So therefore, the reaction will shift more towards the right, making more dichromate, which has an initial color of orange, so it creates a darker orange color. Now, NaOH is considered a strong base. So when NaOH was added, the OH ions from NaOH reacted with the H plus ions, and this neutralized the reaction, essentially forming water. And therefore, the concentration of the H plus ions decreased, and to make up for the loss of these H plus ions, the reaction will shift more towards the left, towards chromate. And because of this caused the color to change from a more orange color to a more yellow orange color. The second reaction I will explain is experiment D, which was a cobalt-cobalt chloride equilibrium reaction by adding a stress of different temperatures. So as you can see, I have the equilibrium equation for this reaction, and the initial color of COH2O6 2+ solution was a light pink aqueous solution, and the initial color of COCl4 2- was a dark blue aqueous solution. And when mixed together, the solution was considered to be at equilibrium and appeared as a purple color. And this purple color was used as a reference for the rest of the experiment. So we added a couple of different stresses to this reaction, and the first stress that was applied was hydrochloric acid, and when adding a stress of HCl to the cobalt chloride solution, more Cl ions were being added, causing an increase in concentration of the chloride ions, and therefore, to relieve the stress, the reaction shifted more towards the right of the equation, or towards the product side, and based on the observations in lab, the cobalt chloride solution turned more blue, or to a darker blue. The next stress that was applied was heat, and adding a stress of heat to the equilibrium solution, it will cause the reaction to shift more towards the right. And because of the shift, the solution will turn to a dark blue color. This is an endothermic reaction because heat is being added as a reactant. Therefore, it is relieving its stress by moving away from heat to the product side. And based on the observations, the color changed from the initial purple-blue color to the dark royal blue because of this shift. The next stress that was applied was putting the equilibrium solution in an ice bath. And based on the observations, the original equilibrium color of blue, purple-blue, slowly started to change to a light pink color. And in this case, this was actually an exothermic reaction because heat is being released as a product, and based on the color change, the reaction will shift more to the left, or to more towards the reactant side to relieve that stress. And this caused the color to change from the purple to the original color of COH2O6, which was initially pink. The last reaction I will explain is experiment E, iron-iron thiocyanate. And here I have the equilibrium equation for this reaction, and according to chemlibretext.org, the initial color of the Fe3+ ion is a light yellow aqueous solution, and the color of the thiocyanate ion is a clear aqueous solution. Before I start explaining the different stresses that were applied, the Fe3+ ions were in the form of an aqueous solution, iron nitrate, and when the iron nitrate was mixed with the potassium thiocyanate, which was also an aqueous solution, the two reacted and produced a dark red color. And because it was so dark, H2O was added to dilute the solution to make it more visible, and this solution was considered the equilibrium solution. The first stress that was added was adding heat. When heat was added, the dark red color of the equilibrium mixture changed to a lighter color. Based on the observations, an exothermic reaction took place because heat is being released, and since this heat is being released, it can be added to the equation as products, or on the product side, and to relieve this stress, the reaction is going to shift more towards the left, or more towards the reactants, causing the lighter color change. The next stress that was applied was adding more iron nitrate and potassium thiocyanate. Based on their observations, the equilibrium mixture of the dark red turned to even more darker red when more iron nitrate was added. And this is because since a reactant is being added to the reaction, it is going to relieve the stress by using up the added reactants and shifting to the right towards the products. And this is why the color changed to a darker red color. Similarly, the potassium thiocyanate had the same reaction because it is also a reactant. In this case, the potassium thiocyanate was added to the mixture, and the concentration of the potassium thiocyanate increased. Therefore, the reaction is going to shift more towards the right, towards the product side, causing the darker red color. The last stress that was applied was adding silver nitrate, and as the silver nitrate was being added, there was a dramatic color change from the original light red color to a white non-transparent color. Based on the observations, the reaction shifted more towards the left because the dark red color is disappearing, and it is going more towards the reactants. A precipitate also formed during the reaction because the silver ions from the silver nitrate reacted with the thiocyanate ions. And because they are oppositely charged ions, they formed a precipitate of silver thiocyanate, which is a solid solution. And this can be written as Ag plus SCN minus 2 AgSCN solid. And based on the reaction, silver ions removed the thiocyanate ions, and therefore the reaction will shift more towards the left to replace the loss of the thiocyanate ions.